Today we're going to cover Unit 6, Acquisition 2, Molecular and Empirical Formulas. So first we'll define what each of those are. When we're talking about the molecular formula tells us how many atoms of each element are in a compound. Think of the molecular formula just like the regular formula that we're used to dealing with. Let's say my formula was C4H8. This tells me I have 4 carbons and 8 hydrogens. This is a molecular formula. The empirical formula is going to be the simplest or most reduced ratio of atoms in a compound. So let's say we have that same molecular formula, C4H8. The empirical formula is going to be the most reduced form. So we can reduce this down to CH2. Also just important to note, different molecular formulas can have the same empirical formula. So let's look at an example problem where you are given some data and you need to, let's start by figuring out molecular formula. Let's say you are asked to determine the molecular formula of a compound given the empirical formula and the molecular formula has a molar mass of 200.04 grams per mole. Determine the molecular formula of a compound with the empirical formula CF2 and a molar mass of 200.04 grams per mole. So, the way that we can easily figure out this problem is by taking the molar mass of the molecular and dividing it by the molar mass of the empirical. So the molar mass of the molecular formula was given 200.04, and I know the empirical formula. So carbon has a mass of 12.01. Fluorine has a mass of 19. 19 times 2 is 38, plus 12 is 50.01 grams per mole. So if we take the molecular molar mass and divide it by the empirical molar mass, you should get a whole number or a number very close to a whole number. So now all we have to do is take this number and multiply the empirical formula by it, which would give me 4 carbons and 8 fluorines. You could always double check, make sure we get a mass of about 200. I could do 4 times the mass of carbon plus 8 times the mass of fluorine and make sure we get about 200. So let's try another problem, but for this one, you're not going to be given the empirical formula. You have to solve for the empirical formula. So let's say we are told a compound contains 40% carbon, 6.71% hydrogen, and 53.29% oxygen. First question. Determine the empirical formula. Whenever you are given a problem where we are given percent compositions, we are going to make an assumption. We are going to assume that the total mass of the compound is equal to 100 grams. That is going to make your calculations much easier. Assume that the total mass is equal to 100 grams. So if the total mass is 100 grams and 40% of it is carbon, 40% of 100 would be 40 grams. And what we're going to do is convert from grams to moles. And the way we're going to do that is a one-step conversion where we divide by the molar mass of carbon. So I can look up carbon on the periodic table. It has a molar mass of 12.01. 40 divided by 12.01 gives me about 3 1/3. We're going to do the same thing for hydrogen and also for oxygen. So again, assume a 100 gram sample. If I have a 100 gram sample and it is 6.71% hydrogen, I have 6.71 grams of hydrogen. About 6 2/3, 6.6. And then I'm going to do the same thing for oxygen. 53.29 grams oxygen divided by its molar mass. About 3 1/3. The easiest way to get these to whole numbers is divide by the smallest number of moles. So 3.33 is the smallest number. Divide all of them by 3.33. This one gets me about 2. And 1. So the steps. If we're given percentages, assume that the sample is equal to 100 grams. That gives you easy math. Once you have your mass, we divide by the molar mass to get to moles. Then we compare all 3 answers and always divide by the smallest number of moles. These numbers become the subscripts in your empirical formula. So I have 1 carbon, 2 hydrogens, and 1 oxygen. Next question. The molar mass or the molecular mass is 180.16 grams per mole. Determine the molecular formula. So again, I already gave you a little equation to figure out what we need to multiply the empirical formula by. It's going to be the molar mass of the molecular divided by the molar mass of the empirical. So molecular was given to us, 180.16. I can calculate the molar mass of my empirical. Carbon is 12.01. 2 carbons, each with a mass of 1.01, which gives me 2.02, plus oxygen, which is 16, 30.03. So now I can do molecular divided by empirical, and that should give me about 6. That means I'm going to multiply every subscript in my empirical formula by 6. Leaving me with a molecular formula of C6, H12O6. All right, let's try another one. And in this example, we're going to be given masses in grams instead of percents. A compound contains 20 grams of carbon, 3.33 grams of hydrogen, and 26.67 grams of oxygen. So first, we will determine the empirical formula. This one should be one less thing to think about because we're already given grams. If we're doing a conversion to solve for moles, we need to start with grams. So just start with the number of grams that are given. I have 20 grams of carbon divided by the molar mass of carbon to get to moles. You get about 1.665. For these calculations, we don't need to worry about significant figures because the empirical formula is going to be a formula. We're not going to record a numerical answer. So don't worry so much about significant figures. So I did my calculation for 20 grams of carbon, 3.33 grams of hydrogen, .297 moles. And then lastly, we're given 26.67 grams of oxygen. Divided by its molar mass. Okay, so we want to figure out the empirical formula. So we have kind of our ratio of carbon to hydrogen to oxygen. But again, the easiest way to figure out our formula is to divide by the smallest number of moles. So 1.665 is the smallest of the three. This one will give me about 2. This one gives me about 1. So for this example, the empirical formula actually is the same as our last example. CH2O. So we have our empirical formula. Now let's figure out the molecular. The molar mass is 120.12 grams per mole. Determine the molecular formula. So again, the equation we're going to use is we are going to take the molar mass of molecular and divide it by the molar mass of the empirical. Molecular was given. Carbon 12.01 plus 2.02 gives me what, 14.03 plus 16, 30.03. 120 divided by 30 gives me about 4. I'm going to multiply the empirical formula by 4, which gives me a molecular formula of C4H8O3.